Alright guys, so in the last example we were talking about multiplying rational expressions. Okay, in this problem, in this example, we're going to be talking about dividing rational expressions. Now, it's pretty much the same except for one step that you have to remember. Okay, so remember when you are dividing fractions, there's a rule that you learned in Algebra 1. Alright, and that is keep, change, flip. So when you're dividing fractions, so for example, if I had, I don't know, 7 over 5 divided by 6 over 3. In order to perform this operation, I would have to do keep, change, flip. So I'd keep this fraction, 7 over 5, change this to multiplication, and then flip the second fraction, and I'm simply just going to multiply across here. Alright, we're going to do the same thing with these rational expressions, okay? So knowing that, in order to perform this operation here, we have to keep, change, flip. And after we do that, it's going to be the same operation as it would when you're multiplying rational expressions. So let's go ahead and do this. We're going to keep, change, flip. So we're going to rewrite this. So the first fraction, the first rational expression stays the same. Okay, then we change to multiplication, and then we flip here. Okay, now you're going to follow the rules just like you would when you were multiplying rational expressions. So again, I like to work the coefficients first. So why don't we go ahead and do that. So working the numerator and working the coefficients, we have 4 times 9, which is going to be 36. Okay? Now let's work our variables. Well, x to the third power times, well, I don't have another x, right? So I'm just going to leave it like that. Same thing with y. Okay, I'm just going to leave it. So I'll have x to the third and then y to the fifth. Okay, now let's work the denominator. So here we go. We have to do 16, okay, times 9. So we have to do 16 times 9 here. Let's figure out what that's going to be. If we do 16 times 9, we get 144. Alright, so we get 144. So again, working the coefficients first. Now let's work our variables. Well, our variables are just going to stay the same here. Alright, now at this point, you're just going to do the operation. So again, work the coefficients. 36 divided by 44. Well, what is that going to become? 36 divided by 144. What will that reduce to? Alright, so let's see here. So 36 does go into 144, it goes in 4 times. So 36 goes into itself once, and 36 goes into 144 4 times. Alright, so we can rewrite this. We'll have 1 over 4. Okay, now let's work our variables. So again, same base, looking at my x, and I'm doing division here, so we subtract the exponents. So 3 minus 2 here is going to be 1, x to the first power, or just x. Alright? 5, and remember there is an exponent of 1 on this y here, so if you want to write it in, you can. 5 minus 1 is going to be 4, so we have y to the 4th power. Okay, and we can rewrite our final answer as x to the y to the 4th power, all over 4. Alright, and that is going to be your final answer for this particular problem. So again, we have x times y to the 4th, all over 4. Okay, and this problem is now done. Alright, let's try another example. So let's erase this work, and let's set up the next one. So we're going to have x to the 5th minus 4x to the 3rd, okay, all over x squared minus x minus 2, okay, and now we're going to divide by, and we'll have here x to the 5th minus x to the 4th minus 2x to the 3rd. Right, then on the bottom we have x squared minus 1. x squared minus 1. Okay, so a fairly big problem here, but again, if you follow your steps, you'll be fine, right? So don't get overwhelmed by this, just follow your steps. So again, first step, keep, change, flip, because we're doing division here, right? So we're going to keep the first one. So let's go ahead and rewrite the first one, change it to multiplication, and then flip. So we'll have x to the fifth minus 4x to the third all over x squared minus x minus 2. So multiply, and now we're going to flip here, so we get x squared minus 1. And we have x to the fifth minus x to the fourth minus 2x to the third. Alright? Alright, so at this point, right, it doesn't look like we can cancel anything out. There's a lot going on there, right? So what you want to do at this point is just work each one, numerator and then denominator, and work on factoring it, and then see if you can cancel anything out. So what I'm going to do is I'm going to look at this first one on this numerator right here, this x to the fifth minus 4x to the third. And I'm just going to factor it. I'm going to see what happens when I factor it. What is going to be the greatest common factor that I can take out between these two here? So if I look at this, I can take out an x cubed, right? If I take out an x cubed, I'm going to be left with x to the second power, right? And that'll be minus 4. Well, if you look at this, now that we took out this x cubed, what do we have going on here? This is going to be called a difference of two squares, so we can even factor this further, right? X squared minus 4, we can write that as x plus 2 and x minus 2. It's a difference of two squares. So what I'm going to do here, I'm just going to erase this because we determined we can continue factoring that, and we're going to have x plus 2 and x minus 2. Okay? So that's this part right here. Let's look at this part, right? So the second numerator. This is also going to be a difference of two squares. It's going to be x plus 1 and x minus 1. And we're multiplying it, so I'm just going to write it side by side here. X minus 1 and x plus 1. Okay? So we just went ahead and we factored out the entire numerator. Alright, let's put this all over the denominator now. And let's work on factoring the denominator. So if we look at this, this is a quadratic. So I'm looking at this problem right here. Okay, I have x squared minus x minus 2. That's going to be a quadratic. Now, you may be able to put this right into factored form. You may be able to visualize that. If not, you're going to use the AC method here. Alright, so we're going to factor using the AC method. A times c is going to be negative 2. What two numbers when I multiply are going to be negative 2 but add up to negative 1? That'll be negative 2 and 1. My a value is equal to 1, so I can put it right into factored form. So we're going to have here x minus 2. I'm grabbing these right here. And then x plus 1. This is now completely factored. Let's move on. What is the greatest common factor I can take out between those three terms? Okay, what can I take out? Well, it looks like I can take out an x cubed. So I'm going to go ahead and do that. Take out an x cubed. And again, we're multiplying, right, our whole denominator here. So I'm just going to write it side by side here. So I have x cubed, right? And on the inside, I'm going to have x squared minus x, okay, and then minus 2. And if you look here, okay, we can continue to factor this, right? We just did. It's the same thing right here. We already factored this. X squared minus x minus 2. X squared minus x minus 2. We already determined what that's going to be. It's going to be x minus 2 and x plus 1. So I can rewrite this as well. I'm going to go ahead and do that. So let me erase that and just rewrite that as x minus 2 and then x plus 1. Alright, so that was the hard part right there. Here comes the easy part. All we have to do is cancel out our common factors right on the top and the bottom. So I have an x cubed. Well, that can cancel out because I have it on top and bottom. Alright, x minus 2, x minus 2, x plus 2, Oops, and I don't have an x plus 2, so I can't cancel that out, sorry. Let me write that again. So what else can I cancel here? X plus 1. Anything else? And it looks like that's all I can cancel here. Alright, so how I'm going to rewrite this, I'm going to have x plus 2, x minus 1, all over x minus 2, and x plus 1. Okay? And that's going to be your final answer. Okay, so you can go ahead and circle this. Now this is done. So again, that was a fairly long problem, but once you went ahead and factor it, all you have to do is cancel out your common factors, right? And that's it. So that is your final answer.